Welcome back. I am now here with another set of new learnings. For today's discussion, I will explain each of the following learning objectives. Number 1, drawing a graph of a polar function. Number 2, finding the area of the region bounded by the polar curve. And number 3, finding the area of the region bounded by two polar curves. A polar function is a way of representing curves in a plane using polar coordinates instead of Cartesian coordinates. To draw the graph of a polar function, you need to plot points on the polar coordinate system. In this system, each point is represented by an angle and a distance from the origin. The angle is measured in radians and the distance is called the radius. To plot a point, you start at the origin and move along the angle for the given radius. Then you repeat this process for different angles and radii to create a curve. You can use software like Dismas or Wolfram Alpha to help you graph polar functions. Now let's say we want to graph a polar function with the radius that is equal to 2 cosine of an angle. To do this, we can plot points for different values of the theta or the angle and their corresponding radius. Here's what the graph looks like. To find the area of a region bounded by a polar curve, you need to use integration. Here is the formula for finding the area, where r is the radius function and theta is the angle. You integrate from theta is equal to a to theta is equal to b to find the total area between those angles. This formula works because it calculates small slices of area using rectangles with width, the change in angle and height are squared, then adds up all those slices to get the total area. Now let's say we want to find the area bounded by the polar curve. Radius is equal to 2 sine 3 theta, and to do this we need to integrate. Area is equal to 1/2 of the integral 0 to pi over 6 times 2 sine 3 theta and then squared, then d theta. So a is equal to 1/2 the integral of 0 to pi over 6, and then since it's squared, so it will become 4 sine squared 3 theta d theta, and that would also be equal to 1/2 the integral of the limit 0 to pi over 6, 2 minus 2 cosine 6 theta d theta. And now we'll evaluate the integral. So we have here 1/2 times the quantity 2 theta minus 1/3 sine 6 theta. So from the angle 0 to angle pi over 6, we'll evaluate it also. So now we have here 1/2 times the quantity pi over 3 minus 1/3 sine pi and minus 0. So now our final answer would be, for the area, we have pi over 12. Therefore, the area bounded by the polar curve radius is equal to 2 sine 3 theta is pi over 12 square units. And moving on, to find the area of a region bounded by two polar curves, you need to use integration as well. So this is the formula for finding the area of a region bounded by two polar curves, where r sub 1 and r sub 2 are two radius functions that bound the region between them. This formula works because it calculates small slices of area using rectangles with width d theta and height r sub 2 squared minus r sub 1 squared, then adds up all those slices to get the total area. Now, for example, we want to find the area bounded by two polar curves with radii 4 cosine theta and 4 sine theta. And to do this, we need to integrate 1/2 of the integral, the limits of the angle from 0 to pi over 4 times the quantity 4 cosine theta squared minus 4 sine theta squared d theta. After simplifying and solving for the integral, we get area is equal to 1/2 of the integral of the limits of the angles from 0 to pi over 4 times the quantity, that's 16 because 4 times 4 is equal to 16, cosine squared theta minus also 16 because it's squared, 16 sine squared theta d theta, and then it will have 1/2 of the integral of the limit of the angles from 0 to pi over 4 times 16. We have factored 16 out, so 16 times cosine squared theta minus sine squared theta d theta. Simplify it, so we have 1/2 of the integral of the interval 0 to pi over 4 times 16 cosine of 2 theta d theta, and that would be equal to 1/2 times 8 sine of 2 theta from the angle 0 to angle pi over 4. Then evaluate the limits. So we have our final answer. Therefore, the area bounded by the polar curves radius of 4 cosine theta and 4 sine theta is 4 squared units. And that ends my discussion. Thank you for listening.